In this lecture, we try to find out the expansion of inverse trigonometric functions. This inverse trigonometric function has very important rule use and also its application. So let us try to first expand what is the expansion of tan inverse of x. So now here, instead of using the Maclaurin series, we can also use the Maclaurin series to find out the expansion of tan inverse of x. But we have another method. If we use that method, then it will be very simplified method to find out the expansion of tan inverse of x. So let f of x equal to y, which can be written as tan inverse of x. Now, if we're differentiating with respect to x, we have what is the derivative of y? It is y1, and derivative of tan inverse of x is nothing but 1 upon 1 plus x square. And 1 plus x square, if we take this in the numerator, 1 upon 1 plus x or x square. So if we take it into the numerator, what is its power? It will be 1 plus x square whole to the power minus 1. Now we know about the binomial expansion of 1 plus x to the power minus 1. It is nothing but 1 minus x plus x square minus x cube plus x to the power 4 minus x to the power 5 and so on. So now if we write down the binomial expansion of 1 plus x to the power minus 1, we write down plus alternate, the power will be x to the power 0 means 1, then 1, 2, 3, 4, and so on. So if the even term will come, we get the positive term, and the odd term will come, we write down negative term. Now we apply this formula into to expand this expression. So clearly we can write down 1 first 1 in place of x, it is x square. So if we write down minus of x square, then x square whole square, then x square whole cube, then x to square whole to the power 4, x to the power 2 whole to the power 5, and so on. If we again simplify it, 1 minus x square plus x to the power 4 minus x to the power 6 plus x to the power 2 4 is 8 minus x to the power 10 and so on. So we have the value of dy dx is equal to 1 minus x square plus x to the power 4 minus x to the power 6 plus x to the power 8 minus x to the power 10. Now let us try to integrate it. So integrating, we have, let us integrate from y equal to 0 to y of dy, and this part from x equal to 0 to x, and this we want to find out the integration of this term. So integration of y is nothing but dy is nothing but y, and y is nothing but tan inverse of x. Now, what is the integration of 1? It is nothing but x. What is the integration of x square? It is x cube upon 3, because we know that what is the integration of x to the power n? Integration of x to the power n is nothing but x to the power n plus 1 upon n plus 1. Here, what is the degree of x over here? X is has power 0. So x to the power 0 plus 1 upon 0 plus 1, we have x to the power 1. Similarly, if we write down in the third part, x to the power 2 plus 1 upon 2 plus 1, which is nothing but x cube upon 3. So just look here in the second term. In the third term, x to the power 5 upon 5. In the fourth term, x to the power 7 upon 7, x to the power 8, 9 upon 9, x to the power 11 upon 11, and so on. So these are the expansion of tan inverse of x. So now just look here, within a very short period of time, we have expanded tan inverse of x into the power of 11 or more power. So this is the beauty of this method. Otherwise, if we want to use the simple general method of Maclaurin series, then definitely we have to differentiate tan inverse of x at least 11 times to obtain this series, right? So that will be more complicated if we use directly the Maclaurin series. So instead of using that, we use this method, or it is called derivative method. So therefore, tan inverse of x is x minus x cube upon 3 plus x to the power 5 upon 5 minus x to the power 7 upon 7 plus x to the power 9 upon 9 minus x to the power 11 upon 11, and so on. So this is the expansion of the function tan inverse of x. Thank you.